All right, for today we're doing 12.4. The student will be able to sequence the steps to find the geometric sequence, the geometric mean, and the geometric series. This is a lot like 12.3. If you understand the terminology from that, it makes it pretty easy to go through this. We'll just have different formulas. So just like before, our sequence, our first term's a sub 1, our second term a sub 2, a sub 3, up to a sub n. The big thing I'm seeing people struggle with, remember when we have numbers here, like with an arithmetic sequence, let's say we're adding 3 every time. Remember, a sub 1 is the value of the number in the first spot. So when they get to a sub n, remember a sub n is the value, but n is the spot in the sequence that it is, whether it's the 10th or 15th spot. The a sub n is the value, the n is just the location. So, again, the sequence is the same thing, except it'll be geometric instead of arithmetic, and a series is still the sum. We have a new term in the geometric mean. So, the geometric sequence is simply the ratio of successive terms is the same. So as an example, if I did 3, 9, 27, 81. So it says the ratio of successive terms, so that would be 9, remember ratio is fraction, so 9 divided by 3, which is 3. So in this case, my geometric sequence is being multiplied by 3 every time. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. If I wanted to find the next number, I'd multiply by 3 and get 243. The common ratio, which is that common change now, is found by A2 divided by A1. And the book, so you know, that will be an italicized R for the common ratio. A geometric series, just like before, a series means we're going to add up all the terms in the sequence. So the sum of the terms in a geometric sequence. So we'll take that combination of this series here, and we add 3 plus 9 plus 27 plus 81 out to whatever point they tell us to. So the work we're going to do on this, so to determine if a sequence is geometric, divide any two consecutive numbers to find the common ratio, again the italicized R. If R remains the same, the sequence is geometric. So our first formula we're going to use is a sub 2 divided by a sub 1 equals R. And so let's take determine if that's geometric. So all we do is we take A2 divided by A1, so 15 divided by 3 is 5, and now we can check it. Is 15 times 5 75? Yes, so then that would be a geometric sequence. They could do something like this. They could go 9, 3, 1, 1/3. And so now we divide A2 divided by A1. Now remember, we use A2 divided by A1, but you could take any two numbers. The same thing we did on 75 divided by 15 is 5. So it can be any two numbers in the sequence. You take the one number and you divide it by the number in front. So in this case, if I do 3 divided by 9, that would be 1/3, and now we check it. Is 3 times 1/3 1? Yes. Is 1 times 1/3? Yes. So that would be geometric. We can also run into this with geometric that we couldn't do before. Okay, so now again, -4 divided by 2 is a -2. Is -4 times -2 8? Yes. Is 8 times -2 -16? Yes. And so it's possible now to have this bounce back and forth between positive and negative. So we can find R and determine whether it's geometric or not. To find the nth term, So let's go back to this sequence right here, and let's find a to the 10th. So our formula is a to the n. Now remember, so this is a to the 10th, so we want to find the value of the number in the 10th spot. Equals a to the 1, 2, times r, which we found was -2, to the n minus 1 power, and so we're at 10, so 10 minus 1 would be 9. And so now we take the calculator, and we do, be careful on these with negative signs. We take, put it in parentheses, -2 to the 9th power. Remember, you should know, since it's an odd power and it's negative, we should get a negative number, times 2. And so it would be a to the 10th equals -1024. Now, a thing you can be careful with on checking these is a to the 10th is an even number, while all our even numbers are negative, so that gives us a good chance to know that we're right. So we're doing the same thing as we did on the last assignment. You could also have the same thing where they skip numbers. Like they could tell you a to the 3 is some number, and a to the 8th is another number, and then ask you to find a to the 10th. Well, remember, we do the same thing. We just make this our A1, and this then, because I would add 5 to this, I'd add 5 to that, that would be A6. We could plug it into the formula, and then we'd have to solve for R, and then we'd have to go back again and solve for A1 using either A3 or A8, and then we'd have to do it a third time to find our a to the 10th. So there's a little bit of work to do, but it's the same as the last section, except you're doing it now with geometric series and sequences instead of arithmetic. The geometric mean, on this, the geometric mean, we haven't done this before, you're not going to be tested on it, but it is on the assignment. It's not very hard to do. It says if a and b are positive terms of a geometric sequence with exactly one term between them, the geometric mean is given by the square root of a times b. So, if I gave you one number in between, all you do is you take the square root of 4 times 64. So you would multiply 4 times 64 and then take the square root of that. So 4 times 64 would be the square root of 256, which is 16. Check it. 16 divided by 4 is 4. 4 times 4 is 16. 16 times 4 is 64. And so it checks. The one thing on this, technically we should put plus or minus here, because it's possible that our r was -4 and we would still get 4 and 64. So if you can remember, I'm probably not going to take off for missing this, but it's nice to put the plus or minus there. And then the last thing we're going to do is the same thing that we did before on a geometric series. So the partial sum of a geometric series is given by the formula. Now remember that technically these parentheses are like this. I can't type it in with this program. But it's a sub 1, and then in parentheses 1 minus r to the n over 1 minus r. And again, the only restriction is r cannot equal 1 because that would make the denominator 0 and we can't divide by that. So let's go back to that first sequence we had, 3, 9, 27, 81. And let's find the sum of the first 10 numbers. Okay? So, a sub 1 is 3. 1 minus, we already know r is 3, to the nth power, 10 over 1 minus 3. So then we just have to calculate that. Now on the calculator, what I would suggest is be careful on how. Sometimes when you put this in, if you try and put it in all at once, you can not put in enough parentheses. So my suggestion is just do the numerator first. So I'm going to go 1 minus 3 to the 10th power. And I get -5,000 So 3 and negative 59,048. And then I'm going to divide that by 1 minus 3 is a negative 2. So I'm going to divide that by negative 2 and get 29,524 times 3. 88,000. So S of 10 is 88,572. Let's do one more of these. So what I'm going to do now is go back to the problem at the beginning of the year that I gave. That I told you if you gave me a penny on the first day of the month and you doubled that every day of the month for the month of October, then I'd give you an A in the class. So if we look at that, well, that would start at 1 cent and then double to 2 cents and then double to 4 cents and double to 8 cents and so on. Doesn't seem like much, but if I plug it into the formula, October has 31 days. So S of 1 is 31, and we started at 1 cent, so 0.01, times 1 minus, our R is 2 in this case, our N is 31 days, and then divided by 1 minus 2. Okay? So now if we go to the calculator on that, that would be 1 minus 2 to the 31st power. So we get that divided by 1 minus 2, which would be a negative 1, divided by negative 1, and then times that by 0.01. And you can see that it would be $21,474,836.47 for 31 days. So, as you can see, a lot of this is just like we did on the arithmetic series and sequences. We just have the formulas are different. Again, my suggestion is on the assignment, just take the time to have those formulas written at the top of your paper, that A2 divided by A1 is equal to R, that A sub n is equal to A sub 1, and then R times n minus 1. The geometric mean is the square root of A times B, and then the sum of the arithmetic series is A sub 1 times 1 minus R to the n over 1 minus R. If you have those there, it's a simple matter of plugging them in. Again, sometimes you have to move things around when they don't give you A1 or AN, and they give you like A3 and A8. You have to manipulate those to find the information you need. But the assignment is page 895, numbers 3 to 35 the odds. Hope you find that fairly easy to do. Good luck.